Measuring temperature is one of the most common jobs in any plant. Motors, bearings, ovens, tanks, process lines. Almost everything has a temperature you need to watch. But here is the catch. A temperature sensor is not one thing. There are 4 common families, and they behave completely differently. One covers a huge range, but is not very accurate. One is precise, but limited. One is dirt cheap, but only over a tiny band. Pick the wrong one, and you lose accuracy, run out of range, or pay for precision you never needed. In this video, I will walk all 4, Thermocouple, RTD, Thermistor, and the IC sensor, and show how each one reaches your PLC. Quick note before we dig in. This is from PLC Simulator, where you can practice scaling a temperature sensor and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, the first sensor type. Start with the thermocouple. Take 2 different metals and join them at a point. That junction produces a tiny voltage that changes with temperature. The effect has a name, the Seebeck effect, and the voltage is small, just millivolts. But it is enough to measure. The thermocouple has 3 big strengths. It covers the widest temperature range of any sensor, from cryogenic up past 1,000 degrees. It is rugged, and it is cheap. The trade-off is accuracy. A thermocouple is less precise than the others. It also needs cold-junction compensation because the reference end adds its own voltage that has to be subtracted out. Type K and Type J are the everyday workhorses. Next, the RTD, short for resistance temperature detector. Instead of making a voltage, an RTD changes its resistance as it heats up. The most common one is the Pt100, a platinum element that reads exactly 100 ohms at 0 degrees. Platinum is used because it is extremely stable and very linear, so the reading barely drifts over years. That makes the RTD the accurate, repeatable choice. The trade-off is a narrower range and a higher price. I'm not going to repeat the full RTD story here. I have a dedicated Pt100 RTD deep dive that covers 2, 3, and 4 wire wiring and the lead resistance problem. It is linked below. Watch that one for the detail. Third, the thermistor. A thermistor is a semiconductor whose resistance changes a lot for even a small change in temperature. That makes it very sensitive and very cheap. 2 real catches. Its range is narrow. It works over a small band, not the whole plant. And its response is nonlinear, so you need a lookup table or a curve to turn that resistance into an accurate temperature. That rounds out to the 4th family, the IC, or semiconductor sensor. That is a small chip that outputs a clean, ready-to-read signal directly. Easy to use, but limited to a small range around everyday temperatures. Good for circuit boards and ambient sensing, not for an oven. So which do you choose? It comes down to 3 things: range, accuracy, and cost. Need the widest range, rugged and cheap? Thermocouple. Need the best accuracy and stability over a normal industrial range? RTD. Need sensitive and cheap over a narrow band? Thermistor. Just sensing ambient on a board. An IC sensor. Now, how does each one actually reach the PLC? A thermocouple gives millivolts, so it needs cold junction compensation at the input. An RTD is read as a resistance. But the most common path of all is a temperature transmitter. The transmitter takes the sensor and converts the reading into a clean 4 to 20 milliamp signal that any ordinary analog input card can read and scale. I cover that 4 to 20 milliamp scaling in the linked analog input video. Let's put side by side. Thermocouple, widest range, rugged and cheap, but lower accuracy, and it needs cold junction compensation. RTD, the Pt100, the most accurate and stable, but narrower range and higher cost. Thermistor, very sensitive and cheap, but a narrow range and nonlinear. IC sensor, simple and direct, but only a small everyday range. 4 sensors, 1 job, for very different trade-offs. Match the sensor to the range and the accuracy you actually need. So here's what to walk away with. A temperature sensor is not one thing. It is 4 families each trading range against accuracy against cost. Thermocouple for range. RTD for accuracy. Thermistor for cheap sensitivity. IC for simple ambient. And most of them reach the PLC the same way, through a transmitter as a 4 to 20 milliamp signal. Get that, and choosing a temperature sensor stops being guesswork. Now, go make it concrete. If you want to practice scaling a temperature sensor hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.